Most of you already know, I'm AJ. So I've been working on this Node library called Greenlock for quite some time. Back when Let's Encrypt first came out, I rushed to get it done because I wanted to be, first to market because open source is a cutthroat world. And the reason I've been working on it is because I see being able to get HTTPS very easily as the first step in re-decentralizing the web and bringing ownership back home, which is kind of my life mission. And for those of you that don't know, I will force my business card upon you during this meeting. And I am working on a home server. So I want to re-decentralize the web, and that's a really techie goal. And well, how do you get everybody in the world to get a home server? Well, you sell to moms that want to take pictures of their kids and get frustrated because it pops up and says that they can't on their phone, and you give an option that lets them sync. And that is what I'm doing to start with re-decentralizing the web, because first we gotta have hardware in the home, we gotta have connectivity to the home, we gotta get the devices that you already own connected, and we gotta get security on those devices so that they can communicate. And that's my whole reason of being involved in Let's Encrypt and developing Greenlock. So they recently updated the version. People call it ACME v2. That's completely wrong. There is no ACME v1 yet. So Let's Encrypt is the brand name. ACME is the name of the standard, the protocol itself, kind of like Gmail is the brand name and email is the standard. Same kind of thing. So Let's Encrypt came out with a v02 of their API, and everybody thinks that it's version 2. So I call it version 2 as well. And I'll show you what it's for real quick before I even get into the presentation. I'll show you the demo first. So I have here, if the demo gods are with us, super crappy. This is the ugliest and most free way to get your SSL certificates. So this actually works. So I'm going to do test.ppl.family, and I'm going to click next. I own that domain, and I'm going to put in my email address here. And I'm going to say I'm going to agree to the Let's Encrypt and the Greenlock terms of service, and I'm going to click next. And then it's going to pop up, and it's going to say you need to validate your domain to prove that you own it. So I'm actually going to log in to name.com, and funniest thing, somebody logged into the site on my computer a while back, and I tried everything, like going into the application settings, deleting the cache. I cannot get their username and password to stop populating, no matter how many times I log in on my own. Anyway, let me take 2 seconds here to find my authenticator code somewhere in this list of like bajillion two-factors that I've got going on. There it is. Okay. So everybody memorize this code. It's going to be valid for a full 30 seconds. If you act fast and you already know my password, you can get in. Okay, now this is scary. You get to see my whole list of domains. There we go. Okay, so here we've got my DNS records, and I'm going to paste in this one that I'm being asked to validate with. And you can do this with DNS or HTTP, but it's easier for me to do it with DNS this way than to bring up the terminal and log into my server. I don't know, maybe that's just as easy, but I'll show you that later. But okay, now I set this TXT record. What's that? Oh, oops, thanks. Good eye. Thank you for that. Yeah, I need to not do that. There we go. And I could get rid of these old ones from previous demos. Oh, dang it. No, I wanted this. There. Okay. I can do this. All right, cool. So now I go back over here. I'm saying I'm going to validate with the name server. I click next. Doot, 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 doot. And voila! I have, unfortunately, these are actual, real, I have to blur this out in the video, maybe. Oh, well.
I don't think that nobody wants to type that.
Well, yeah.
Right.
The thing is, that if that's not what that in the video, someone can actually type that, transport it, post it on it. I was going to get it. At least I'm not.
Okay. So anyway, now I am going to, I think it actually, yeah. I'm going to go into this test directory. I've got Node.js installed on this server. So I'm going to do privkey.pem. Well, I guess it's not so bad because it's just the test domain. So maybe we can work with that. I doubt somebody's going to hijack my test domain and do anything useful with it. Okay, so I take those certificates. I make my little node program here. I run it. I go to test.people.family. It says hello world. So to prove this to you, I quit that. Nothing. Right. So that was Let's Encrypt running in a browser. And I actually have here we go. So I actually have the instructions on how to create that here, going step by step by step. And it's like a bajillion D steps. So we're going to do that in summary. But this is the browser version, and I'll show you the automatic version later. Yeah, so no. The DNS record was actually set to the server that I'm running this on. Whoa, what did it do that for? Let me. This is why I don't use Google Hangouts. Cool, it's back. So there's like 7 different kinds of lag here, but it's cool. So where were we? Oh, so this right here, I'm actually logged into a demo server. So you see root here at demo. So this VPS was already set up in advance with that IP address. Yeah, but I could do it localhost because I did DNS validation, so that would work. So if you, yeah, this is great for that kind of thing. The DNS validation is perfect for when you have private networking that you want to secure. So anyway, that process we went through, we got a real HTTPS certificate. We got it for free. And now I'm going to tell you, this process has also been automated, and that's what my Greenlock library is. I've got a couple different libraries of the different layers of abstraction. But I want to tell you about the process that we just saw happen, and I'm going to shorten it because, like I said, it's like a bajillion D steps. This is ACME is a very handshaky protocol, and I mean, as you'll see, it looks noisy. Like when you break the pieces apart, of course, they're simple. But when you look at it all in whole, it's like, whew, that's a lot of stuff to do. It's like OAuth 2 times 10, you know? So if you've ever like done OAuth 2, like once you get it, like conceptually, it makes a lot of sense. But the first time you go to do it, it's like, there's 15 different handshakes in this. And in Let's Encrypt, there's a few more. So, yeah, the low-level library that I've got is ACME v2.js. The high-level one is Greenlock. We're talking about Let's Encrypt v2, which is actually ACME draft 11. So it might become ACME v1, and people will probably call it ACME v3. Like I was saying, there's lots of things. We'll start with key generation. And what you need to know about key generation is that there are account keys and domain keys. And so you can think of this like the client, which is sometimes your web server, the Let's Encrypt client, which could be your phone, could be your laptop, but most likely in the very simple case, the very non-enterprisey, like I'm just some dude putting up a web server case, most likely the client is running on your web server. So that's a little confusing. But the Let's Encrypt client is what has an account key, because Let's Encrypt is smart and they don't use passwords. They use key pair authentication. So you basically submit a public key to them, and that is your account identifier. And we'll see that part. And then there's your domain key pair, which is a separate key pair. So in the enterprisey scenario, your client is some like load balancer manager thingy-mabob that's making sure that the certificates are always fresh, or it's maybe even more abstract than that. And then the web server itself, there might be 3 different keys for the different web servers, so each physical server that's handling the SSL might actually have its own domain key or its own server key. And so that's where like this is a spec that's built for enterprise. You can use it as an individual, but you have to understand that there's things that seem superfluous that they're not, because it's built to scale to enterprise scale. So domain keys and account keys are separate. The domain key is what your web server uses to take the certificate that's been signed with the web server domain or server key and serve it to the browser, and then the browser uses that public key to verify. The account key is only used with Let's Encrypt. It doesn't have anything to do with your browser or your web server, except that the Let's Encrypt client is likely running on your web server. So half of my examples were with RSA keys, half of them were with ECDSA keys. But I'll just show you this is what the RSA key generation process looks like in Node. So there's like 10 different libraries to do RSA keys, and none of them are complete. So I created this library that joins them all together and in the darkness binds them, called RSA compat. And that gives you like all of the functions that you need across Node's native libraries, plus Forge.js, plus another library called URSA. So anyway, I recommend using this if you are new to RSA and Node, because it's just going to work. It's going to work whether you have build tools on your system to compile native modules or not. And that's the main advantage to it. But the API is pretty simple. I'm actually going to have to change it a little bit. So it only takes one option instead of these different parameters. But it's like key length, exponent, which why you're allowed to specify exponent, I don't know, because everyone uses the same exponent and the other exponents are considered insecure or something like that. But this number is a power that you're raising a prime number to. I'm going way too deep into that. It doesn't matter. This is what it looks like to generate a private key. You write it to a file is either PIM or JWK. Those are the 2 things. So this is what a PIM file looks like. This is a hecka long prime number, essentially. ECDSA keys are way shorter because they're like any random number. And then this is what it looks like as a JWK. So just so you have some perspective of what a key looks like, that's what it looks like. And you can generate a public key is essentially a private key with the private parts deleted. So if I wanted to turn this into a private key, or I mean a public key, I would delete like Q and DP and DQ and QI, and I would just leave like E and N, I think is the only thing that gets left over. Anyway, so there's this concept in Let's Encrypt of ACME of a directory, which is great. There's a new version of OAuth called OIDC, or it's technically not OAuth, but it's OAuth, called OIDC, and they have this as well, where there's one URL from which you get all the other URLs. Because if you've ever signed up for a Facebook developer account, you know it's so annoying to have to go track down like in your OAuth library, where's this URL, and what does it look like, and where's this URL, and what does it look like? And then when you go to do integration with some other OAuth provider, like all the URLs are different, and the parameters are sometimes different, and it's just super obnoxious. And so there's this kind of new idea of going towards directories for APIs, and Let's Encrypt does that, and it's awesome. So there's a directory for the staging API, which is this top one here, which it will issue you fake certificates. I mean, it's the same technology, it's with a certificate authority that's not listed in your browser, so it'll give you a red warning instead of a green lock. And then the second one is like the real one. When you're doing stuff with Let's Encrypt, like even if you have a pre-built library that works completely accurately like Greenlock does, I should hesitate to say completely, but I think it's completely accurately. It's working for lots of people, but there's probably something somewhere that, some edge case. But anyway, you should always start with staging, because most likely you are going to do something wrong, and if you just restart the server over and over again, then you're going to reach your API limits and you're going to get blocked and you won't be able to get your certificate. So even if you're using something that's like fleshed out and works, start with the staging API, get a bad certificate, then delete your certificate, important, and then restart with the production API once you know that it works. Because you might have a firewall problem where your HTTPS port's being blocked, or you might be trying it out on localhost and forgetting that you have to use a DNS challenge to do that, or whatever. That directory URL, anyway, they return back the same format of thing. So the couple of important things here are new account, new nonce, and new order. Oh, and also the terms of service under meta. So these things let so you don't have to go figure out these URLs. You just need to know that it's called new account and new order, and then your application, once it gets fetches from the directory URL, it has all the other URLs that it's going to need. And then other URLs that you need that aren't listed here are actually given to you as part of the response. So you can build a client without having to hard code any URLs except for that. So I don't know why that slide was there. We talked about that already. So this is what it looks like to create an account on an ACME client. So that's the Let's Encrypt account, or the ACME account. First thing is you have to get a nonce. And whatever flow you're doing with Let's Encrypt, you always start by getting a nonce, which is to mitigate replay attacks. And what that looks like is this. So you'll recognize this URL from right in here, new nonce, and you can see that it's basically the API URL /acme/new nonce. So that's what we're looking at there. When you make that request in Node, it might look like this. So you're simply going to get that URL. So I have this variable called directory that supposedly holds all of those strings. And then you're going to check, I'll explain that in a second. But you get, actually I think this was browser code that I wrote, not Node code, so I lied. But it probably works in Express. I think they have a get method on the headers object. Anyway, you look for replay nonce, and you need that. So basically, if you can imagine somebody giving a special order, if you were to record their voice and they leave the room and you play it, whoever is obedient to them would go and do that thing. So there's an attack where even if something's encrypted, if you can manage to record it and replay it, you could potentially get the audience that's receiving that message to do something, and you could potentially cause harm. So the purpose of a nonce is that whenever you receive a message, if you've ever seen the message as nonce before, you just ignore that message because it's either a mistake with network connectivity or it's a replay attack. So every action that you perform that is a creative or destructive action, a write action of some sort with the ACME API requires a nonce. And the reason that I put this little if here to check to see is because it turns out that you might as well just include this little bit in every single request that you make with the ACME APIs, because you need a new nonce every single time you use the previous nonce. So anything that you've done that used a nonce will actually return to you a nonce. So that way you always have a fresh nonce. So then we actually get to move on to what we wanted to do, which is create an account. And so that URL looks like this, which is familiar from before. It comes from the directory URL or directory payload. And you have to make a request in a format called Jose. So more and more standards are including Jose. So Jose is basically, JSON object signing and encryption or something like that. But it's like JWK and JWS and JWT and Jose and all those things all go together. And this is what it looks like in kind of a simplified form. As you're making a request to a URL, the method's post. The header, this is actually important. The header must change the application type, the content type, not to application JSON, but to application Jose plus JSON. So I don't know why that's particularly important, but parsers will actually fail if they're strict parsers if you don't change the content type. And that's a sticking point that you might not, like it can get you hung up and you see this error message, could not parse, and you're like, what do you mean could not parse? And then it turns out it parsed it just fine, it just didn't like it because it was missing a parameter. And then we have the body, which this looks kind of cryptic here, but bing. And I'll expand these out, but basically a Jose request has 3 to 4 parts. This one doesn't use the header, but there's sometimes the header, then there's the protected, then there's the payload. The payload is the thing that you actually want the server to receive, but the protected and the header include information that basically just help with security. And then the signature is going to be the protected and the payload concatenated together, or potentially the header, the protected, and the payload concatenated together, and then shard, and then run through a signing algorithm. So what that starts to look like is a protected, in the case of ACME, looks like this. Your nonce goes in the protected, and that kind of makes sense because the data you're sending to the server, like the nonce is not important as part of the data. It's not important as part of like how you're creating the account. It's just something that needs to be there for protection. It also lets you know that the algorithm that it's expected to use, before I was using RSA, this example is showing ECDSA. So ES256 is the algorithm, the URL that this was posted to. So to me, some of this seems like almost superfluous in terms of like how tight their security is. But it's like if the audience URL receives a message and that message was not intended to be posted to that URL, that message does not pass. So every time you post a message, you have to say, you have to post it to the URL you're intending to post it to, but in your protected, you're saying, this is the URL I intend to post it to. So it's kind of like if at any point in the application there's a security leak in any part of the chain of whatever there could be, is able to get access to your data. It can't do a replay attack. It can't even take the data and then send it to the wrong URL. I mean, so they're really paranoid about that, and I guess that's good. And then the JWK is the account key itself, the public key for the account that's auto-generated from before. And I tend to save this in relation to the email address that goes with the account. So that's what the protected look like. And this is the payload. This is the thing we're actually using to create the account, which is, do we agree to the terms of service? Do we want to only return an existing account if there is one and an error if there isn't one? Or do we actually want to allow creating an account as well? So for some reason, it seems a little bit inverted logic, but you say only return existing false means yes, I want to create a new account. But it means that if you already have that account, it will just return the account ID to you from before. So it is an idempotent transaction. And then contact, which can be a URL, which I don't know what their webhook API is for URLs, or it can be an email address. And then the signature is you sign protected plus dot plus payload, and then you use your private key, and you get back your signature. And the reason that these all say 64 is because they have to be base 64 encoded URL safe. So it's slightly different from average base 64. So here's that whole thing all in one go. Yeah, that's what it looks like when you put it all together. And it's just like, brain explode. There was one other thing I was going to show. I thought I had a slide where I actually showed the final request. Oh no, I showed that at the beginning, that's why. So that's what it looked like. So basically, every request in the ACME standard goes through this process. And this request right here, in fact, does return a nonce because it was required to have a nonce in order to make it, so it returns a nonce. So then if you save your nonce from this request, you are ready to make your next request. One thing about nonces in the way that they work with this API, since you need a different one for every single request, you need to serialize the requests or you need to go fetch nonces ahead of time. So like if you want to verify 10 domains, a common mistake would be that you go try to verify all 10 domains. Just put it in a map, return promises, promise.all, and then get back when all 10 have been verified. You either need to go get 10 nonces and then verify 10 domains, or verify one domain, then the next, then the next, then the next, then the next, and so on. And for most use cases, that's probably safe enough to do. If you're doing more than like 20, then maybe you do want to implement the logic to go get all the nonces and then verify all the domains. But yeah. So anyway, that is the shortened version of like the most critical pieces of what the ACME spec and the Let's Encrypt API look like. And then I want to show you one more demo. So I showed you the semi-manual. I mean, like, had anybody gotten a SSL certificate before Let's Encrypt? It was a pain in the butt process. So even though that, click next and having to log into my account might have seemed like, oh, that's a little painful, before it was really painful, and it cost money, which was even more painful. So let me, where'd my little test server go here? And I think I've got Greenlock Express already installed. Let me just make sure I've got the latest version. Nope, examples, vhost. So here, with this library, it will go ahead and talk to Let's Encrypt, but when it gets back those challenges, it'll set it up as an HTTP challenge, and so it will actually get a special request that asks for that token rather than the token being checked for in a DNS record. And when it gets that special request, it automatically replies to it. And so this one, oh, it's doing it. See, it's taking a second. It's going through the process. It's getting verified. It created an account. Hopefully I haven't hit my limit because I've done this demo so many times and you're only allowed to get like so many certificates per week, and I might be over my limit. No, I'm not. Yes. So there we go. So that was the entire process that we went through the very first time manually, completely automated away, built on the code that was more or less what you saw on the screen. So HTTPS for everyone! Yay! Questions? I should have asked for questions throughout. I'm going to sit here for a minute because I know you've got some. If you care at all about Let's Encrypt, which some of you may not, that's totally fine. It's kind of boring.
So in the first version, you got a form, it gave you public-private key pair, you copy and pasted it into a file, store that on your server. So now you have those in a durable format, you can keep reusing it. But the HTTPS one, where does it, was that just for verifying the certificate, or is that?
No, it actually stored it. So it's pluggable. So here, that's where it went. If you see that on the screen, that's where it went. So yeah, so Greenlock is a pluggable system. So you could use, like somebody wrote a module for S3, somebody wrote a module for Route 53, somebody was working on a module for Mongo, but I don't think they ever finished it. I'm pretty sure somebody did complete a module for Redis. So you can search on NPM. Let me just do it real quick. LE challenge hyphen, and it'll come back with all of the, yeah, so somebody's got the Redis one, somebody's got for Cloudflare, somebody's got for S3, somebody got etcd. I have no idea what that, interesting. But yeah, DigitalOcean. So different people are integrating with Let's Encrypt in different ways, depending on the service providers that they use. And then LE Store is the other one. And so somebody's got a module for console. Somebody's got a module that I should actually switch to be the default if it works, because mine was based on the old certbot storage directory, and it wasn't the best in the world. So yeah, you can build your own based on your needs. So as complex as your system is, you can make a module plugin that's that complex, but it fits into, it's a total of 8 callbacks that need to happen. Create an account key, save an account key, or check that an account key exists, create an account key, check that a domain key exists, save a domain key, check that a certificate exists, request a certificate, or save a certificate. And then I think there's 2 more somewhere. But you can, if you fill out those functions with the right function signature, then you have a storage for whatever you need it for.
Follow up to that. So when I did an SSL search before, that was looking at it like one time, and was intending to never do that again. But this system would be set up where I could do this quite frequently. What's the use case where I would need to get lots of certs like that?
So if you do virtual hosting, or if you use domain names like subdomains, like say for user accounts or something like that, and this does it automatically. So the manual process was manual, but Greenlock Express and Greenlock, if you were to integrate it into any other Node solution, is automatic. So it actually, there's a callback deep in the bowels of Node that I'm like the only person that's ever used, because one time there was a glaring API error with it, and if anyone had tested it at all, they would have found it. But deep down in the bowels, there's this thing called SNI callback. And so every time a TLS packet comes in, it says, I'm a TLS packet, and the thing I want a certificate for, or to start the encryption handshake for, is this domain name. And so it'll actually check that and then check to see the certificate date. And every so often, so this is just stored in memory the entire time your server's running. Every so often, it'll do a check again and say, like, oh, do I need to update this certificate? Oh, do I need to update this certificate? So most of the time, it's just going straight through, but then occasionally, it'll check. And so over the course of the next 75 days, eventually it'll be like, oh, it is about time to change this certificate. Let me go ahead and set a timer on it, and it'll set a random timer, and then it will go and fetch it. And the reason it sets a random timer is because if you were virtual hosting, and let's say that you implemented Let's Encrypt for the first time, or Greenlock, or whatever, some solution for the first time, and you're going to fetch 100 domains, well, and then you add like another so many domains. If you were to try to fetch all those domains at once, you could hit your account limits for domain renewals. And so it's just got a little bit of a random timer to say, like, once it notices that it's within the grace period, which is 14 days, actually I think it might, yeah, it's between 14 and 10 days is the standard grace period, and then like the emergency grace period is between 10 and 0 days, and then it expires. So it'll just pick a random time and then renew the certificate, so it staggers it out. That might have been too much information, but whatever.
So does this kind of reduce the need for a wildcard?
It actually will do wildcards as well. So it does, in most cases, yes. You wouldn't need a wildcard because you can get 50 certificates at a time if you need to. But it does support wildcards as well. And wildcards must be done through a DNS challenge. Because HTTP, every single domain it has to connect to. Because wildcard, you can't connect to every single possible domain. That one has to be done via DNS. But the standard supports it, and Greenlock supports it as well. So like literally, I want you to see one last thing. Oh, is it over here? No, that's not it.
Figure out how to use this, and I could save you $600.
Yeah, so let me show you how to use it. It is literally this simple. Like you, I can delete this directory here and show you. So boom, gone. Hopefully I didn't have anything that I wanted to save in there, like uncommitted changes or something, because sometimes I have that. I'm pretty sure I didn't, because I'm pretty sure I'd done this demo like 5 times in a row. So I just copy and paste this. Node just changed versions, so it's going to come up with an error message here. Yeah, but it's actually totally okay. The error message didn't matter. So I'm going to go into Greenlock Express, examples, simple. All I need to do is change the email address to a real email address. And then I just need to change the domains that are going to be listed on the certificate to the real domains that I actually need. And then I'm going to run this. That's it. So that's literally how simple it is. Now, I am going to add something because you still, this was built with the idea that you have some sort of node service, and so that service is going to be running continually, and that you're going to require this into the node service and then supply your Express app. What I'm actually going to do to make it even a touch simpler is just have a vhost module where all you need to do is specify the directory where your domains are. So you mkdir blah blah blah.com. If blah blah blah.com exists on the file system, it will approve it to fetch the certificate for that. So I showed you the super simplest example, which was with a hard-coded list of domains. And if you scroll further down, it shows you how to build a dynamic example where it's going to go, it says, this is where you check in the database or whatever you need to do to find out what email address should be used for this domain. Have they accepted the terms of service? Where on the file system do these files live or whatever?
I'm just going to keep asking questions just to understand what actually happened here. So the little app that you ran, so if I wanted to stand up a server that corresponded to HTTPS in the olden days, I would go get a certificate, somehow attach it to my server, request comes in, the browser needs to get a certificate to verify that I'm who I am. I look that one up, I hand it back, blah, 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 it all works. In this case, that little app that you stood up, you didn't yet have a certificate.
Correct.
The request came in, the app's like, oh crud, I've got to get one. It goes and does all the stuff with Let's Encrypt, gets one, and then is able to respond to the incoming request and everything works?
Yes.
Okay. Wow, that's pretty cool. Yes.
So this, in the stupid simple example, which I tell people not to use, but we all want examples that are, like one-liners, right? This list is the only allowed domain. So if I provide an array, then it's going to grab all of them that are in that list all at once, and every time it renews, it's going to renew the entire list. If I use the approveDomains callback as a function, that's where, this is one of the places where if I was building a hosting service, which I might be, then I would have the stuff in here to go check my database for what user does this belong to? Have they accepted the terms of agreement that are, with this version of Let's Encrypt? Do I need to send them an email to let them know, hey, terms of service have updated. As soon as you hit reply to this, your certificates will renew. If you don't, they'll expire in 15 days or whatever. So all of that type of stuff, that logic would go on in here. Now, there is a danger here that I need to figure out a way to fix. The SNI callback in Node swallows errors. And this was an intentional decision by the Node team because I don't know exactly why, because we had some back and forth on it on GitHub, but they made an informed decision that they wanted to just let it swallow errors. So if you have an error in this function, and I think I can do something like, I need to do like a try catch around it and then spit out the errors, because I think right now I'm passing, I wrap it once and I pass it to the SNI callback, and that one, if there's an error, it just swallows it because there's no way to handle it gracefully. So the options were, if there happens to be an error for some reason, your server crashes, or there's silent errors and the browser just loses the connection, they thought that it was more appropriate to not have your server crash and to just let the browser have an undefined error and have to go digging for it. Which most of the time, like, if it's wrong, like my argument was, if it's wrong, it's usually going to be wrong every single time. So if you're building a service for the first time and it's not working, then you know that something's wrong because you can, follow my tutorial and my test and see that that works, so you know that something that you did is wrong. But I got a mental note, and actually I'll put an issue in right now to throw an error for approved callback. Cool. Other questions? You can ask another one if you want.
Oh, I was going to ask on the wildcard, something about a DNS question with the wildcard registration through this.
What about it?
Does this automatically handle it, or is that something you have to?
So I actually had a name server before that would automatically handle it, and I will have a name server again that automatically handles it. Right now, I don't. So what you could do is, this one is kind of a LE Challenge DNS is a demonstration of basically how to build it. So I have, it'll print out to the screen like, go update your DNS record to this, then hit enter, that kind of thing. So if you're running the service in the foreground, this will work for that use case, but you have to integrate with the DNS service that you're using. And I think currently, if we go back and look, Route 53 has been implemented, Cloudflare has been implemented, and DigitalOcean have been implemented. So if you're using any of those, it'll work. I'd love someone, or Azure. Apparently if you're using Azure, that's implemented as well. So, yeah, but I do have slated in this next month to finish my name server and to get my domain service back up, and so then I will publish my own module for DNS. And if you use my name servers, either hosting them yourself or you purchase or transfer your domain through the service I'm creating, then you will be able to have that work automatically for wildcards. So no, so like I was talking about before, like my goal is to re-decentralize the web, right? Like I want to be able to own my stuff again. And in order for me to be able to own my stuff again, I have to force the entire world to own their stuff again. So there has to be like this mass movement, and there has to be like groundswell and all that. So I'm building all the tools one by one. I'm building the server. And along that path is, one of the first steps was SSL. Having a dynamic name server, having a tunneling service, all of the things need to be so that you can self-host them on your own. But most likely, I think about it, like as long as you have the feeling like, yeah, I can run this as open source software on DigitalOcean for $5 a month, I'm much more likely to let someone else run it for $5 a year. And so that's kind of my hope, is that on the path to building the product I'm trying to build, which is the home server, which I believe is a good profitable business, I'll have some other opportunities along the way where I'll let you pay me per month or per year for some of these things. Like the domain service is probably going to be $15 a year, which like as developers, you guys know that you could get that cheaper through GoDaddy or Namecheap or whatever. But realistically, I think that you'll probably like paying $15 a year because you'll have the convenience. It'll work with the suite of tools. Everything will be integrated. And you'll be like, if I want to switch, I can use this open source software, and I can pay GoDaddy, and I can set everything up on DigitalOcean. But AJ was so nice to do it all for me. Here's a tip. Have $7 on top of my domain.